Thank you everyone for joining this talk about the terror-free guide to introducing functional Scala at work without dying in the process, featuring ZIO Prelude. My name is Jorge Vásquez. I'm a Scala developer at Scala. And by the way, our company is looking for Scala developers. So if you want to know more about that, you can visit our careers page. What's the agenda for today? Well, first, we're going to discuss about the motivation around the ZIO Prelude. Then we're going to take an overview about the library. And finally, we're going to see how ZIO Prelude can help us to being happier in our developer lives. So the motivation for ZIO Prelude is boilerplate. So boilerplate is a problem we have to face every day when we are developing software applications. We sometimes need to write some complicated code that in reality it should be a lot easier. So what I'm going to do now in this first section of the presentation is showing you 7 examples of typical cases that you can find when you are working in your applications. And I'm sure you have a lot more examples than the 7 ones I'm going to show here. So let's go right there. So as a first example, let's suppose we have some cache stats data organized in nested maps by date and location. This data comes from 2 sources, and we need to combine them into one, some encounters when collisions exist. So it should be really easy. So let's say this is our cache stats structure. So as you can see, it contains several counters, all of them encapsulated inside of options. And you can also realize that some of them are integers and the other ones are longs. So for the example, suppose we have these 2 maps here. As you can see, they are nested structures. And for combining them, we can simply use, for example, the ++ operator in maps for combining them. But if we look at the result, sorry, we will have some issues. For example, here, I'm combining this sum 1000 value with this non value, and I'm getting a non. But actually, because I want to sum counters, I'd like to obtain a result of sum 1000, but I'm getting a non. So what's happening? Well, you know the ++ operator is lossy, right? So in this case, when I'm combining 2 maps, the second map will always overwrite the first one. And that's why I'm not getting the expected result, but actually the second map is overriding. So we can implement another solution. And in this case, I'm implementing a custom combination method first for combining cache stats. You can see the code looks pretty crazy because I need to take care when combining cache stats. I need to look at how to combine these options correctly. And also I have to take into account that, for example, some of them are integers and others are longs. And then I also need to implement a combination method for combining the nested maps. And you can see here the code looks even crazier than the before code I've presented. And these maps aren't even that complicated. But now that I have implemented all that boilerplate code, finally, I'm able to obtain the expected result. So here I'm obtaining sum 1000 as I was expecting. Another example of a boilerplate, let's suppose we have a list of cache stats data and we want to sum all stats. So again, I have my cache stats structure. I needed to implement the custom combination method that looks pretty ugly. And here I have a sum method for combining this list of cache stats. So For this example, I'm using fold right, and I need to decide this zero element here, and I have to be very careful about this zero element, because if I don't choose it correctly, weird things can happen, and I needed to use this custom combine method. So boilerplate again. Let's take a look to a third example. Let's suppose we have several options and we want to combine them into an option of a tuple. So here, I want to combine just these 10 options. All of them are options of integers. And look at this code. It looks pretty complicated, and the task is actually easy. So I'm calling zip several times, and then I need to destructure these nested tuples to obtain the tuple I want. So a lot of boilerplate for doing a very simple task. In our next example, let's suppose we request some person data from 3 different servers, and we want to return the first successful response or a failure if all the requests fail. So in this case, let's suppose we have this person structure with this data like first name, last name, and others, and I have this getPerson method. This one here is just a mock implementation that returns the requested person encapsulated inside a try. In this case, for the example, I'm using the try that comes from the Twitter library, not the try that comes in the standard library. So here I'm requesting the person from 3 different servers. And for obtaining the desired results, here I have this ugly looking code. First, I try the first server. If that fails, I try the second server. And if that fails, I try the third server. So that solves the problem, but it looks kind of ugly. So it's something difficult. In our next example, let's say now we have a binary tree of integers. So in this case, I want to obtain some statistics data from the tree. For example, what's the minimum value? What's the maximum? Is the tree empty? Is it non-empty? What's the sum or the product of the elements? What's the reverse tree? So for that, it's pretty easy, right? I can implement my own binary tree structure, nothing special there, but I need to implement a lot of methods for being able to answer to the questions. So I had to implement all of this and all of this, a lot of boilerplate. And finally, after having written a lot of custom methods that, by the way, I'd also need to write a lot of unit tests, I'm able to answer to the original questions. But it was too much to write. In our next example, we have still our binary tree, but now let's say we have binary trees of persons, and I want to obtain what's the youngest person, what's the oldest one, what's the average age, or how many people are there per location. For answering this last question, I need to implement a custom group by method. And you can see it's not too easy to implement. It's something complicated. And after doing that, after adding more boilerplate, I'm finally able to answer the questions. And finally, one more example with the binary tree. Let's say now we have a binary tree of strings, and we want to send those strings to a server which just echoes the received messages encapsulated inside a future. And I want to obtain a future of a binary tree containing the responses. For that, I need to implement another custom method, this method named for each future, that will process each element of the tree that has type A and return a future of B, combine all those futures into a future of a binary tree. After having done that, I can call this echo method I've implemented here on the messages tree using my custom method for each future, and it will behave as expected. However, what will happen if echo returned a try instead of a future or an option or an either? Well, we could implement, for example, for each try or for each option and so on. So we will need more boilerplate if we decide to change the effect type. So boilerplate is everywhere in these solutions. So now I wanted to tell you that there is a better way. And here is where ZIO Prelude enters into the scene. So what is ZIO Prelude? ZIO Prelude is a new library. It's a Scala first take on functional abstractions. It gives us several things. The first one is data types that complement the Scala standard library. For example, you have non-empty lists, non-empty sets. You have Z sets that are multisets. You have Z non-empty sets, validation, and ZIO. You also have new types. New types allow you to increase type safety in domain modeling, wrapping existing types without adding any runtime overhead. And finally, ZIO Prelude gives us type classes to describe similarities across different types. So we can eliminate duplication and boilerplate. So we can eliminate this boilerplate, for example, in business entities like person, shopping cart, or we can eliminate duplication in effect-like structures like try, option, future, either, or in collection-like structures like list or our custom binary tree. So now we are going to revisit the original 7 examples, but now we are going to use a ZIO Prelude and see how it can help us to make our lives a lot easier. So the first example was we have our cache stats data organized in nested maps, and we wanted to combine those maps, summing counters when collisions exist. For that, ZIO Prelude offers us a solution, the associative type class. The associative type class offers us a combine method that allows us to combine two values of the same type A and return a result of the same type A. And now, if you're thinking why this type class is called associative, is because this combine operation needs to obey to this associativity law. So if you try to combine 3 values, it doesn't matter in which order you combine them, you should get the same result. By the way, here you can see this symbolic alias for the combine method that also comes in ZIO Prelude. ZIO Prelude has associative instances for Scala standard types. For example, Boolean, integer, long, float, lists, sets, tuples. And the same happens with other type classes. ZIO Prelude has instances for Scala standard types. And of course, we can create instances of associative for our own types or types on third-party libraries. So going to the solution using ZIO Prelude, we had this cache stats structure with the counters that are options. And now we need to implement the logic for combining cache stats. Before, we needed to implement a custom combination method that took care of how options are combined, for example. But now it's a lot simpler. We just need to import ZIO Prelude, and that's it. And we can implement the associative type class for cache stats. So here, I just need to provide the implementation for the combine method, and the combine method should return another cache stats. And you can see the logic is pretty easy here. I just need to combine the counters, and that's it. And for combining, I'm using the combine symbolic operator here that comes also from ZIO Prelude, and it will work. Why? Because as I've mentioned, ZIO Prelude already knows how to combine options, for example. So I don't need to implement a custom logic for combining options. And it also knows that when combining the options, it has to sum the internal values. Why? Because if you see here in the cache stats case class, each field has a type of option sum of int or option sum of long. This sum is a new type. I've mentioned new types before that comes in ZIO Prelude that helps it decide how it will combine values. So for example, if I wanted to multiply the counters instead of summing them, I just need to use the prot new type instead of sum. And now that we have implemented our instance, you must be wondering if there is some way of knowing that your associative instance is implemented correctly. And the answer is that there is. All type classes in ZIO Prelude include a set of laws that instances must obey. And we can use ZIO test to check that laws of a type class are fulfilled by a given instance using property-based testing. So here is an example of how to check that the cache stats instance for associative obeys laws. So here you have the spec. You can see it's pretty easy. You just need to check all laws for associative for cache stats, and that's it. Here are other details, like for example, how you can generate random cache stats objects, but that's something from ZIO test, and I'm not going to go into too much detail about that here. And now the solution for our problem was to combine the two nested maps. I can invoke the instance of associative for these nested maps. ZIO Prelude already knows how to combine maps, by the way, and it also knows how to combine cache stats now because we have provided an instance. So we will be able to obtain this instance and call the combine method on it. But this still looks a little ugly. The good news is that instead of doing that, I can simply use this combine symbolic operator, and that's it. We are going to obtain the expected results, and the syntax is pretty easy. So magic, we don't need to implement our own combine method for nested maps. In the second example, we had a list of cache stats data, and we wanted to sum all stats. For that, we can use the identity type class that comes from ZIO Prelude, and it adds additional power to associative by adding an identity element to the associative operation. And it also has to obey some laws. So for that, for implementing the solution, now we have, and we can implement the identity type class for cache stats in a very similar way to what we did with associative. And for implementing the sum method for combining the list of cache stats, I'm still using fold right, but now I can use the identity element that comes from the identity type class. I don't have to wonder anymore what's the identity or if it's the right one, because that's provided by this identity type class. And I can use the combine operator from ZIO Prelude. I don't have to write any custom logic. So we don't need to implement our own combine method. In the third example, we wanted to combine several options into an option of a tuple. For that, ZIO Prelude offers us the associative both type class that allows us to combine, in this case, type constructors. So the previous type classes allowed us to combine entities, simple entities, business objects, and now we're combining type constructors. So for example, associative both allows us to combine type constructors and return a tuple. And there's also an associativity law that must be obeyed. So again, ZIO Prelude has instances for Scala standard types. And look how easy it is now to combine all the options. I just can use the associative both tuple and method that allows to pass up to 22 objects and combine them into a tuple. So a lot easier than before. You don't need to combine manually now. In the fourth example, we have this person data, and we wanted to request it from 3 different servers, and we want to return the first successful response. For that, we can use the AssociativeEither type class that also allows us to combine type constructors, but in this case, instead of returning tuples, it will return eithers. So if you remember, in my original implementation, I was using the Twitter try type as my effect. So I'm implementing the AssociativeEither instance for it first. And after that, the solution turns out to be pretty simple. Now, for obtaining the response from these three different servers that call this getPerson method, I can just do a declarative I'm saying response 1, or else response 2, or else response 3, and that's it. And obviously, I could keep adding or else's here for trying alternatives. So we have seamless. And we had our example of a binary tree of integers. We wanted to obtain several estimates. And if you remember, we needed to implement a lot of custom methods. Now we can use instead the Traversable type class from ZIO Prelude. As you can see, it offers us a lot of methods. But the good news is that we only need to implement the for each method, and all the other methods will come implemented for free. So now we have our custom binary tree structure, and I'm implementing the Traversable instance for it. For that, I just need to implement the for each method, and that's it. And just as an example here, I'm implementing and overriding the implementation for map that comes from ZIO Prelude with a custom implementation, just for performance reasons. So that's another lesson here, is that if you want to implement a more performant version, so now I can answer all the original questions, and I just needed to implement for each, and that's it. So we have lots of methods for. We had a binary tree of persons. We wanted to obtain again some data. And in this case, we don't need to do anything else because we already have the Traversable instance implemented for binary trees. So we can just use methods that from ZIO Prelude. For example, I can obtain the youngest and oldest person using min by option and max by option, and I can also obtain the average age or grouping persons by certain criteria. The only problem with this is that, for example, for obtaining the minimum and maximum, those will get returned inside options, and that makes sense for structures that can be empty, but that's not the case for this binary tree. So there is an even better solution, and it's using non-traversable. Non-empty traversable adds more power to the traversable class, and just need to implement this for each one method. So now I'm doing that for binary tree. I'm implementing the non-empty traversable type class for it. And now for obtaining the youngest and oldest person, call the min by and max by Prelude. And now the answers won't be returned inside options. So that's more magic. And finally, we had our binary tree of strings. We want to send them to a server which echoes the received message, and we wanted to return a feature of a binary tree. We don't need to do anything. We already have a traversable instance implemented for the binary tree. So we can just call this for each method that comes in the type class with this echo method we want to call, and that's it. And if we were going to change the effect type of this echo to be a try or be an option or an either, that's no problem. We don't need to implement any custom logic like before we needed to have different versions for different effect types. So magic everywhere instead of boilerplate everywhere. So in summary, there's a lot of boilerplate in our applications. Abstraction is the key to eliminating boilerplate, and functional code uses type classes for abstraction. ZIO Prelude has type classes that let you eliminate boilerplate across business entities. For example, we have the associative and identity type class. Across effect light structures, we can use the associative both, identity both, associative either, or identity either type classes. And we can also eliminate boilerplate across collection-like structures using Traversable or non-empty Traversable. Special thanks to Functional Scala organizers for hosting this presentation, and to John DeGose for guidance and support while preparing this presentation. And thank you a lot for attending. If you want to learn more, you can take a look to the ZIO Prelude project on GitHub, or you can take a look to these other talks, the first one by John DeGose and Adam Fraser in YouTube, and this other one I've given before in Scala's functional world about exploring ZIO Prelude. You can contact me on Twitter or GitHub or by email if you like to ask any questions.